Hi students, today we are going to discuss two advanced topic of relations, that is called partial order relation, okay, and followed by equivalence class. Okay. If you remember, in our last session we discussed about a reflexive relation, symmetric relation, transitive relation, and also an anti-symmetric relation. Now a relation rho defined on a set S will be known as a partial order relation if it satisfies three properties. One is called reflexive one, second one is anti-symmetric, and third one is transitive. Clear? So any relation rho defined on a set S will be known as a partial order relation if it is reflexive, antisymmetric, and transitive. Let's see. So this is a non-empty set S, and rho is a relation defined on S. Okay. So S is a non-empty set and rho is a relation defined on S. Now, rho will be a partial order relation if and only if number one, rho is reflexive, number two, rho is anti-symmetric, and third one is rho is transitive. So you know what is the meaning of reflexive? Formal definition of reflexive is that A rho A, okay, holds true for all A belongs to S. You know what is antisymmetric? A rho B and B rho A implies A equal to B for AB belongs to S. And you know what is transitive? A rho B and B rho C implies A rho C for A, B, C belongs to S. Let's see an example. Let us consider capital N, the set of all natural numbers, and a relation defined on it is, suppose what I am saying is that N is a set of all natural numbers and a relation defined on it is like that, less than equal to. So we can say that x comma y belongs to that relation less than equal to, which is equivalent to the statement x less than equal to y if actually x is less than equal to y. Obviously. Here is the symbol and here is the actual meaning of that operation. Now obviously it is very clear that relation less than equal to is reflexive because x is less than equal to x for any x belongs to s. It is antisymmetric. Why? You take two elements x and y, and if x less than equal to y and y less than equal to x implies what? X equal to y. So what I am saying is that suppose x is less than equal to y and y is less than equal to x. That means here a row b and b row a kind of stuff. X less than equal to y, y less than equal to x. That obviously say x equal to y. So that proves that it is an antisymmetric relation. And transitive obviously, let's take three elements x, y, z. X is less than equal to y and y is less than equal to z. That implies obviously x is less than equal to z. So it is transitive. So less than equal to operator on any set of natural numbers or real numbers is a partial order relation, and this tuple is generally known as that S and rho is known as partial order set, or it is known as poset. Okay, partial order set, it is known as poset. What is that poset? Poset is the set and that partial order relation together is known as a poset. Clear? Okay. Thank you. Just have a look into it for some 1 minute, and next topic we are going to discuss is called equivalence class. Thank you. Okay, let's continue our next topic called equivalence class. Sorry. Let us consider a set S and equivalence relation rho defined on that set S. So these two are known to us. One is a set S, which is obviously a non-empty set, and equivalence relation defined on that set rho. So what we have? We have the set S and an equivalence relation defined on rho. Then equivalence class is actually corresponding to an element in the set S. Okay, what is that? Let us take an element A belongs to S. Now equivalence class is actually related to the element A, and it is denoted by the symbol A. That is the equivalence class. Now what is it? It is a set. More precisely to say, it is a subset of the set S. containing those elements which are related to the element A by means of the relation rho. I have said several things. Let's describe this in a set notation by means of a set builder form. So what is that? This is the set of elements X such that X belongs to S and X rho A holds true. So this is called equivalence class corresponding to the element A. Similarly, for the other element B of the set A, we can construct another equivalence class. Let us understand by means of an example. Okay. Let us consider a set capital N, the set of all natural numbers. Okay. And a relation tilde defined on N such that X tilde Y if and only if X minus Y is even number. Obviously, this relation tilde is an equivalence relation. If it is not an equivalence relation, then there is no question of discussing equivalence class, right? So this is an equivalence relation, very obvious. We have already discussed several times. Because x minus for any element x minus x which is 0 is an even number. If x minus y is an even number, then y minus x is also an even number. If x minus y is an even number, y minus z is an even number, then their summation x minus y plus y minus z, that is x minus z, which is also an even number. That means x tilde z holds true. So it is a transitive relation. So reflexive, symmetric, transitive. That means tilde is an equivalence relation. Now let us construct the equivalence class for the element 1. What it will be? It will contain, according to this definition, it will contain those elements x such that x belongs to S and x tilde 1 holds true. What does it mean? So this implies what you can write. 1 is equal to those x such that x belongs to S and x minus 1 is even number. Now x minus 1 is even number. That means x must be an odd number, right? So this implies is equal to 1 such that all x such that x belongs to S. Oh, I'm sorry, I made a mistake. By quoting S here, it should be N. Why? Because we consider the set capital N, the set of all natural numbers. So here it will be N. Okay, and x is odd number. More precisely to say that when I say even number, it should be a positive even number, because the n is a set of natural numbers, so it is a positive odd number. Now let's see what is 2. Sorry, not 2, 3. 3 equal to what? X belongs to S, x belongs to N, and x, all x such that x belongs to N, and x tilde 3 holds true. X tilde 3 means what? X minus 3 should be an even number. X minus 3 even. That means x has to be odd number. So similar thing what we see is that it contains x such that x belongs to n and x is positive odd number. Odd number. So what we see? The set as represented by bracket A, that is the equivalence class of 1 and equivalence class of 3 is same. So what we see? Equivalence class of 1 is equivalence class of 3. In a similar manner, you can see 5 in that way. Now let's take the other case. Okay, what is 2? Equivalence class for the number 2. It will be x such that x belongs to the set of natural numbers and x minus 2 is even, positive, obviously positive even number. That implies what? That implies 2 equal to x such that x belongs to capital N. X minus 2 is even. That implies x is also even and x is positive even number. Similarly, if you consider the equivalence class for the element 4, it will be again the x belongs to n and x is positive even number, going to the same logic. Okay, so that will be equal to 2. That will be equal to 6, like that. So what we see is that the set of all equivalence classes are classified into two things. One is the equivalence class represented by all the odd numbers, and the other one is that the equivalence class represented by all the even numbers, both positive odd numbers, positive even numbers. Okay, and here comes few very important properties. Okay, what are those properties? Well, let's see. Here I can write. Okay, any two equivalence class, suppose S is a set and rho is an equivalence class, equivalence relation defined on S. Then the equivalence class of A and equivalence class of B means two elements A and B of the set S should be either equal or they are disjoint. That means intersection of equivalence class and equivalence class of A and B should be a null set. Any one of these two must have to be true. You can observe this by means of the example what I discussed earlier, is that equivalence class of 1 and 3 are either equal and 1 and 2 are disjoint, because equivalence class of 1 represents all the positive odd numbers and equivalence class of 2 represents all the positive even numbers. Correct? This topic, equivalence class, and what I discussed earlier is partial order relation, quotient. These are important, to to answer some questions from IIT JEE, some descriptive question. It is important, and at the same time, this is the foundation of advanced mathematics. Once you are going to study in your engineering, first year engineering mathematics, that leads to the equivalence class, leads to partition. It is a topic of higher mathematics that you can read later. It is not a part of this class. Thank you and good day to you.